Hi, welcome back to the last question of the November 2012 paper 1 for the Namibian Senior Secondary Certificate of Higher Education, higher level mathematics paper. Alright, let's get into it. So here we have, on television, a weather forecaster uses a diagram of a cloud as shown below, so this little cloud shape. Its perimeter consists of a straight line AE, two semicircular arcs, and a major arc of this one. Alright, AE is 8. Okay, all of this information they've given us here, and they say X is the midpoint, so we can already do that. These two parts are equal because X is the midpoint of BD. Good, and the center of the circle is C, so that's the center of this circle. Good, now for the question A, use the trapezium ABDE to show that BX, this distance, is 2.648. Alright, so what we want to do here is, this is actually probably the most difficult question of this whole question 12, because if you can get this part right, the rest is easy. The first part is just to be able to see that if we draw in an extra line here, it makes our lives a lot easier. So if we draw this in, and we can probably do the same here just because of symmetry, but the important part is just to choose one of them and work from there. Right, once we have this is now a 90-degree triangle. We can do the same thing this side. So now we can find this length here, right? So if we find this length, let's see how we can do that. We've got a right angle triangle, we've got the hypotenuse's length, and we've got one angle. So if we want to find this will be the adjacent side, right? So we can say, to start off with, for question A1, cos, because we're adjacent and hypotenuse, so we want to use cos. So cos of 65 equals adjacent, which we don't know, divided by the hypotenuse, which is 3.2. Now to get x, we can multiply both sides by 3.2. So we'll get 3.2 times cos of 65 equals x. Okay, let's work that out on our calculator. So 3.2 times cos of 65. So that's 1.352 something. Oops, let me just do that again and copy this, and then I'm going to paste it over here. So that's our answer for x equals x. Okay, so why did we want to do this? Well, if this part is 1.35 something something something, that's the same as this part. So if we know this whole line is 8 centimeters long, we can say 8 minus double this, right? So for this part here, we're just going to say 8 minus 2 times that. I'm just going to drag that in here. 8 minus 2 times that will give us the length of BD. Will give us the length of BD. This length here, which is the same as that. Alright, what does that give us? So 8 minus 2 times this. 8 minus 2 times that. That gives us 5.295. I'm just going to do 5.295. I think that should be sufficient. 5.295 is BD, which means BX is equal to half of that. So 5.295 over 2. So BX, we know BX is half of BD, so let's just divide that answer by 2, and we get 2.647 something. Let's write this whole thing down and then round it off. Okay, so we get that, and then we can round that off to 4 significant figures, so 2.64, and now we see the 7, we look at that, the one next to it on the right is a 6, so it rounds the 7 up to an 8. So there we have BX, correct to 4 significant figures, is 2.648. Okay, good. Let's go to the next question. Show that angle BCX, where's BCX? This angle here, we need to find that angle, is 62.0 correct to 1 decimal place. Okay, we already know what BX is, so we know this is 2.648. Okay, so we again have a right angle triangle over here, so we can find that angle. So we've got an opposite and an hypotenuse, so that gives us sin. So we've got the sine of an angle that we don't know, let's call it the angle C, equals opposite 2.648 over hypotenuse of 3. Now to get angle C, we say C equals arc sine, or as we call it in school sometimes shift sine or second function sine of 2.648 over 3. So C equals, let's type that on our calculator. Let's see if I can find, oh yeah, we can do it that way. So arc sine of 2.648 over 3. And that gives us this value here, which we can round off to one decimal place, which will mean the 6 makes a 9 a 10, and that makes this one a 62.0. Perfect degrees. Okay, let's continue. So far so good. Question 3, A3. No, not A3. Question B. I'm misreading. Question B. Calculate the length of BE. Let's draw that in to say what we're working with. From B to E. Okay, how do we find this length? Well, we've got this length, we've got that length, and then this angle. What about this angle? If we have this angle, we can use the cosine rule. Now the thing is, we know that these two lines are parallel. So because they're parallel, we know that we can use the co-interior angles here. So we know this angle will be 180 minus 65. So angle D is 180 minus 65. And that gives us 115 degrees for angle D. Okay, so now we can use the cosine rule for BE. The cosine rule says BE squared is equal to the other side squared added together. And we saw this side here was 5.295 for BD. So that's 5.295 squared plus 3.2 squared, the other side, minus 2 times the other two sides. So 2 times 5.295 times 3.2 times the cosine of the angle in between those two sides. And we just saw that's 115. Cosine of 115. Alright, so BE squared equals, now this is quite a long formula, right? Let's type all of that in our calculator. We'll get 5.295 squared plus 3.2 squared minus 5.29, or 2 times, sorry, minus 2 times 5.295 times 3.2 times the cosine of the angle in between, which is 115 degrees, and that gives us this figure right here. Let's paste it over there. Whoa, my bad. Oh, okay. Let's paste that over there. Yeah, erase this little glitch. Okay. Then finally we have to find the square root of both sides to get BE by itself. This is something to pay some attention to. I see it often in exams when people forget to take the square root at the end. So that's why it's useful to write this down all the way to the left. Because we often tend to write down BE squared, write this down, put an equal sign, and then not put this part down again. But it's quite useful because then we can see it's still squared. Alright, take the square root of this figure. So square root, and that gives us 7.25. I'm just going to do 7.25. I think that will be sufficient. Centimeters. Also remember to write your units if there are units to write down. In this case we know it's centimeters, so we write down centimeters. Great. Now we get to question C. Question C. So 4 questions in question C, and then we're done with the paper. Find the area of triangle BCD. BCD. So this triangle. Let's see if we can just color that in to see what we're talking about. So B to C to D. So this area. Alright. So this area, this is nice. We know this is a right angle triangle. So we can use the half times base times perpendicular height formula. So the area equals half times base times perpendicular height. So we know the base, we know is 5.295, right, BD. The perpendicular height on the other hand, we don't know yet. So to find this height, we can use a couple of things. We can use Pythagoras here, or we can use sine, cos, or tan to find this one. So I'll probably For a bit of practice with trigonometry, let's use sine. So we found this angle was 62. So for this angle, we know that the hypotenuse is 3. We also know this value, but I prefer to use values given in case I made a mistake somewhere, in general. Now in this case, it would be fine because we already told that this should be the value, so we know that's right. So I'm just going to use cosine again. So to find h, I'm going to say the cosine of 62, not 65, of 62, this angle, is the adjacent, which is cx, over, actually let's call it h because we want to use h in our formula. So the height over the hypotenuse, 3.2. Multiply both sides by 3.2, so we get 3.2 times the cosine of 62 equals our perpendicular height. And that is again something we've got a calculator for. Luckily we don't have to study the tables anymore like long ago when we had to study the sine tables. You had to know what cos 62 is, you had to know what cos 62.1 is. Same with logarithms. Glad those days are over. Okay, 3.2 times the cosine of 62. That gives us 1.5. Okay, so 1.5 equals h. Now we can plug that back into our formula. So area equals half times the base, which was 5.295, right, from there, times the height, which we just found is 1.5. Okay, multiply those together. So we take that times 5.295 times 1.5. And that gives us 11.9. Is that right? Something seems strange here. Okay, well let's just do that. Copy that value and paste. Okay, so that is the area. Let's round that off to 11.93. Okay, so that's the area of triangle BCD. Good. Then, what can we do next? Well, that's actually, yeah, that's the answer. That's what we want, right? Area of BCD. Good. That was that question. Next question, C2, is the area of the trapezium. Let's do that one in blue. Area of the trapezium. Well, this is getting quite messy, all these different colors. Okay, area of the trapezium. So how do we calculate the area of a trapezium? Well, you don't actually need to know that formula. You can split it up into two equal triangles like we did here, or you can split it up into a triangle, and a rectangle. All of that is pretty straightforward. I'm going to just write down the area of a trapezium, the formula for that, in case you want to know that. Area of a trapezium is half times the sum of the parallel sides times the perpendicular height. Okay, so the parallel sides obviously are these two. So we're going to have A equals, again, before we continue, let's first find the height. So the height, the perpendicular height will be that one. So that again we can do with trigonometry, or we can use Pythagoras. Let's use trigonometry. So we can say the sine of 65 degrees equals the opposite, which is what we want, h, over this length here, 3.2. Okay. I see what I did wrong in the previous question. My bad. My apologies. Okay. In the previous question, I'm just quickly gonna do that again. So let's just erase a little bit of what we did and get back to here. My apologies. I'll put timestamps on where the error was and where the correction comes in. Okay, for this area, to find h, I used 3.2 instead of 3 there. I was looking over here. My apologies. Okay, again, let's say to find cx, we can say cosine of 62 equals the adjacent side, which is the h we want, divided by the hypotenuse, which is 3, not 3.2. We multiply both sides by 3 and we get 3 cos 62 equals h. And again, let's type that on our calculator. So 3 times cosine of 62. 3 times the cosine of 62 degrees, 1.4. Okay, so 1.4 equals h. Let's put that back in our equation. Half times the base value, which is the 5.295 times the perpendicular height, which is 1.4, and let's work that out. So times 5.295 times a half. So 3.73 if we round that off. 3.73. All right. Let's get back to the next question. Second part of question C, the area of the trapezium. Here, let me just draw that in blue again. The trapezium. Okay, area of a trapezium is half times the sum of parallel sides multiplied by the perpendicular height. So again, we need to find the perpendicular height. The sum of the parallel sides we know this is 8, we know this is 5.295, and so we just need the perpendicular height, which is this part. So again, we can use trigonometry. We can say sine of 65 degrees equals the opposite, which is what we want, over the hypotenuse, which is 3.2. Multiply both sides by 3.2, and we get 3.2 sine 65 equals h. So here we go, 3.2 times the sine of 65, that'll give us a h of 2.9. So 2.9 equals h, and we can plug that into our area formula. So half sum of parallel sides, so that's 5.295 for the parallel sides, plus 8 times the perpendicular height of 2.9. Okay, let's type this in the calculator. I'm just going to say this whole part, we can see that's going to be 13.295. Okay, so we've got the height times the 13.295 times the half, 0.5. That gives us 19.28 if we round that off. 19.28. So that is the area of the trapezium. Then what is next? Let's do one in black. We haven't done one in black in a while. The area of the major sector BCD. Okay, so what is that? That is this part. Oh, and this is going to be tricky to keep it sort of on the line. That's this area that we need to figure out. Okay, so how do we do that? Well, we know it's just a fraction of the circle, right? So what fraction of the circle is it? Well, the fraction is the angle, so that'll be this angle, over 360, which is a full circle, times by the area of a circle, pi r squared. So it's just this fraction of a circle. So how do we get that theta? Well, we know this is 62. That means this is 62. So together this makes 124. So this part will be 360 minus 124. 360 minus 124 is 236. Okay, so we've got 236 3/60ths of a circle with a radius of 3. So 3 squared. Just plug that in a calculator. 236 over 360 times pi times 3 squared. And 3 squared is 9. That's 18.54 if we round that off. So 18.54. Good. And what do we have left? What color should we use? Let's use, yeah, we're probably back to green, I think. Back to green for the third one. Because this was already the third one. That was the third one, so we've got the fourth one left. The total area of the cloud diagram. Okay, what do we have so far? In the red, we've calculated this part here. This was 3.73. Then we calculate the blue part, which was 19.28. So 19.28 for the trapezium. Then we calculated the black part. The black part here was 18.54. So 18.54. So what's left? Just these two little outside pieces. Those two little outside pieces. So let's do them in green. Okay, so that's half a circle, that's half a circle, right? Semicircle. They told us that in the question here. So it's semicircles. So if we calculate the value of 1, we can just, well, it's just one full circle, right? So it's just one circle with a radius So pi r squared will cover both of these together. And what is the radius of this? Well, that's the radius. The diameter is 3.2, so the radius is 1.6. So we can say the area equals pi times the radius, which is 1.6 squared. All right, let's do that on the calculator, and then we're almost done. So pi multiplied by 1.6 to the power 2. Oh, not 3, not 3. To the power 2 squared. So 8.04. 8.04. Okay, now all we need to do is add up all the different things, and that's a full area of the whole cloud diagram. Okay, so we're going to add all this together. Let's do that. Okay, so this is our area of, this is the green area, plus the black area is 18.54, plus the blue area 19.28, plus the red area 3.73. That gives us 49.6. So 49.6 is the area of the whole diagram. Okay, this was quite a long and involved question with lots of ugly decimals. The ugly decimals is probably the worst part of this question. Okay, hopefully that helped. And again, if you used any different methods on any of the parts of the question, please let me know in the comments below. And then we can discuss that and see what is the easiest or what is an interesting method to solve it. Thanks for watching, and I'll be back with some more old papers.